Alright, I'm just going to have to try and make this work as well as possible. I'm having a lot of trouble with the light. Used to get ambient light from the... well, anyway. So hopefully you can see what we're doing is two equations, two variables. Okay, here's the problem here. 12y plus 8x equals 24, and 5y minus 2x equals 10. What we're trying to do when we're using the elimination method is to find one of these coefficients that's the multiple of another. In other words, a way that we can multiply one of these to get one of the other coefficient that has the same variable. Okay? It happens to work out for this one because we know that 4 times 2 is 8. Okay? And we already have a negative sign in front of this 2, which means we don't have to worry about being able to subtract 8x from 8x because we already have that negative sign there. So all we need to do then is put some brackets around this second equation and multiply it times 4. Okay? We're multiplying every element in that equation times 4. So 4 times 5 would be 20y. Remember, all we're doing with this second equation is just transforming it. We are not changing it per se. We're not changing the relationship between these variables. We're just transforming it. Let's say this is the most simplified version of this equation. We're making it less simplified because it's going to make it easier to solve the overall system of equations. 4 times 5 was 20y. 4 times negative 2 is negative 8x. And 4 times 10 equals 40. Ascreet's on strike still. He still thinks I need to pay him for all this. This gets him publicity. I don't know what the deal is. He's got an ego problem. Then all we have to do is add this equation to our transformed version of this equation. Okay? We're just adding the first equation to the transformed version of the second equation. So 12y plus 20y will be 32y. Are you able to see that? Yes, you are. 8x minus 8x will be 0. We don't have to put the 0 there. I do it just so that you can see the method to my madness here. And then 24 plus 40 is going to equal 64. You see that? All we did was transform this equation by multiplying it times 4. As long as we multiply every element by the same number, it does not change the solution to the problem. Okay? Or divide it by the same number, or add the same number to it, or subtract the same number to it. As long as we're doing the same thing to each member of that equation, it doesn't change the overall result. Okay, now we need to have the solution here, 32y plus 0 equals 64. We don't have to worry about that 0 now because it's 0, it's nothing. And we know that to solve this part of the equation, all we need to do is divide by the coefficient. Okay, because the coefficient divided by itself is going to be 1. And 1 times y is y. Let's make that y a little thicker so it's easier to see. 40, I'm sorry, since we divided the left-hand side by 32, we have to divide the right-hand side by 32. 64 divided by 32 will be 2. Okay, does everybody see that? 32 over 32 is going to be 1. 1 times y is y. 64 also divided by 32, because whatever we do to the left-hand side, we have to do to the right-hand side. 64 over 32 will be 2. Now we have one solution, which is that y equals 2. So now let's take this and substitute it in to this top equation and see what x is. So we've already discovered what this is. Now we have to discover what this is, this x. If we wanted to, by the way, we could put it right back into this equation here. Okay, just ignore the 4 and the brackets and everything and just put it right back into that original equation. But I'm going to use this one. Okay? Is everybody all caught up with me? All right. If not, just rewind and watch it again. The wonder of technology. And also get rid of this so we can see our original equation. Okay, we're substituting y equals 2 into here. 12 times 2 plus 8x equals 24. All we did was substitute the y that we got from solving the elimination part of this solution. All we do is we substitute it in here. Y equals 2. So 12 times 2 plus 8x equals 24. Okay. 12 times 2 is 24 plus 8x equals 24. We see a 24 on both sides. That's going to give you an idea of what the solution is going to be. Let's subtract 24 from each side. (24 minus 24 is 0. 8x remains the way it is. And 24 minus 24 is 0. We divide each side by 8. And we're left with our solution. X equals 0. 0 divided by 8 is going to be 0. So y equals 2, which we got from the last set of steps that we had taken to get y through the elimination portion of the solution. Now, how do we know that this is a correct equation? We have to substitute it back into our original equation, and it has to work, into our original equations, so it has to work in both of them. Okay? Yeah, I'm going to step back so you can make sure you got this all. I'll get out of the light. 12 times 2, which we found from our original solution to get y. 12 times 2 is 24, plus 8x equals 24. We subtract the constant. We remove the constant, the very first thing, which is our first step when we get to this part of an equation. That leaves us with 8x is equal to 0. Now you can either do this in your head or go ahead and go through the motions of dividing the coefficient by itself. 8 divided by 8 is 1. 1 times x is x. 0 divided by 8 is going to be 0. Now does this work? Let's try it. Our solutions were y equals 2 and x equals 0. And by the way, it is the convention to express this solution as an ordered pair. That is 0, 2. Whoops. 0, 2. That is, this is the x and this is the y. That's the convention to do so. Okay? Let's try substituting. 12 times 2 plus 8 times 0 should equal 24. We know that 12 times 2 is 24, and 8 times 0 is 0, so 24 does indeed equal 24. So it works in the top equation. Let's try it in the bottom equation. Let me get out of the way so you see what I did. We're just substituting the bottom equation now. Times 2, because y equals 2, minus 2 times 0 should equal 10. 5 times 2 is 10. 2 times 0 is 0. So 10 does indeed equal 10. Okay? Now I had to take the day off today because my daughter was ill, and when it seemed like she was okay, we continued the Monopoly game that we've been playing. I'm kicking her tail. I'm beating my daughter at Monopoly. That's pretty impressive, even though she's 6. Anyway, I'll see you all tomorrow.